Hey, Jawad. Hey, Nandan.
Hello. Good morning.
Morning. Oh, video and all.
No idea. This is the first time I'm doing this meeting, and I have a big 15-inch monitor. So
No,
right now, sadly, I'm only looking at myself, which is not a great sight. So it would be great to see all of you too.
well, we typically only the presenter turns on their video.
Hey, Mark!
Hello.
Pleasant surprise. Anu, how did you let him in?
We love Mark.
Who doesn't? It's like there should be a new series that says everybody loves Mark.
Everybody loves
Oh,
Mark.
that's so sweet. Thank you.
Hey, Jawad.
Oh,
I
Jawad
think
put
we
on this
spoke.
video, and so did Mark. That's a new one for this meeting.
Yeah, and Jawad is kind of flaunting his Hawaii credentials.
That's right. I'm just enjoying my Friday 8 a.m.
The way to enjoy a Friday 8 a.m. is after this one to go to the beach. But yeah.
Good one.
Cool.
We usually wait till 8:03. For some reason, Bapi said that's standard.
Actually, that is US standard. In the UK, we used to wait for 7 minutes.
7 minutes?
Oh,
Yeah. I mean, it also gives the people who joined early a little bit of time to gossip a bit and get to know what's going on. In the UK, that's, as Mark knows from his past life as well.
Yeah, you
There's,
need time to make tea.
Of course. What would life be without a good cup of tea?
That's why companies like Intel already have built that in. The meeting started 05.
I guess 07 works okay if it's a 1 hour meeting. If it's half-hour meeting, 07 sounds rather odd.
That's fair. That's fair. Amazon solved that problem as well, because every meeting starts with 10 to 20 minutes of reading of the documents that were sent ahead of time in prose. So you can come in late to a meeting.
Really?
Yeah.
10 to 20 minutes?
Yeah. So the format is 1-pagers, 2-pagers, 4-pagers, 6-pagers.
Oh, wow.
So it's for 6-pagers, they expect you to read for 20 minutes. Most of the time, people get carried away, and 6-pagers have exhibits that actually make it 9 to 10 pagers. So,
Okay.
nobody from AWS is on this call, is there?
No, there aren't. So you say whatever you want. Unfortunately, it's being
Okay.
recorded too, Nandan, so you may want to.
It is recorded.
Yes, it is a recorded call.
So,
It's going to be on the internet forever.
yeah.
Hey, John. Okay, so there you are. Now I can hear you. Sort of, maybe. Anyway, let's get started. Today's agenda was basically Nandan from Biosystems talking about the company as well as the vision for chiplets and AI and all the fun words we like to put together in a sentence. Before we start, I have one item I wanted to mention. We're starting the new Workstream, the chiplet system Workstream. The first meeting is on Tuesday, 12 to 1. The 3 leads are Durgesh, Itai, and Rob. It's been interesting to get the scope together. It's been, I think, really timely and much needed by the industry. I posted on LinkedIn. I sent email out to the groups. Please do join that meeting. It's 12 to 1 Pacific time. Bring your own lunch. And it should be a fun start. So we're going to try to do it weekly basis to start with. Once we gain momentum, we'll see how things go. So my little advertisement for that group, and then I will pass it on to Cliff for any other OCP related announcements.
Well, thank you, Anu. And I guess the only specific thing I have right now is that the call for papers for OCP APAC Summit is open. We have allocated a full day, hopefully to fill a track on chiplets and advanced packaging. And hopefully some people here in the community will find a way to make it out to Taipei City in August. That's the 5th and 6th. And if so, please do put in a proposal to speak. We very much need representation from the community. And if you can't make it out and you're in a larger company where someone else from your company could make it out, please please pass it along.
Great.
Jawad, anything else, or we get started?
I think the only other thing is, so proof of concept work stream, next meeting will be at 10 a.m. today. That's just short announcement, that's all.
Okay, is that Zoom link on the wiki page, or is that
It should
nothing?
be. I did test it and I think it's there.
Oh, okay, let me go check so that
It's there. I'm looking at it right now.
oh, perfect. Thank you. Okay, so so the two work streams that are now getting a new lease to life is the proof of concept, and then the other one is the chiplet system. So do join and let's take it in the right direction. So now I will let Nandan, who I think a lot of you may know already. He talked at the Chiplet Summit. He's well, I'll let him introduce himself. Nandan, it's all yours.
Thanks. All right. So, so Nandan Nampally, I'm the Chief Commercial Officer at Biosystems, and a startup member of OCP. I think Mark and I go back a long way. We were at Denali software together doing memory controllers. Then he continued down the EDA path. I went to ARM for 16 years. And then since then, I've kind of jumped back into a startup world. So I'm assuming this format is like 25 minutes or whatever's left of the 30 minutes, and then some questions. So I'm trying to keep it high level. There'll be slides that are there that we can just rush through. Really, it's more of a conversational discussion. Right? And for most of the people on this team, I think I obviously come more from the digital side, from the system design side, as opposed to a lot more of the detail. How do you actually make it happen stuff that you guys do? Right. So this is, again, preaching to the choir. You guys understand why SOC challenges are exploding, right? That the data movement gap is widening. So our bias focus, as you can tell, is really about efficient data movement, right? And what we see, the common trend, which I'm sure you are as well, it is really about different types of compute coming much closer together. So the need for intelligent compute is very, very clear, right? So close collaboration and close coupling of these compute elements. You've seen the SOCs try to do that, but everything is hitting a limit now, right? And so if you want to actually combine best in class, you also have to be capable of understanding that the delivery mechanism may be chiplets, because you want to squeeze everything out of each component sub-platform. If that happens, then how do you actually put together the best in class, which would mean multi-vendor, reuse standards, etc. And that's a non-trivial problem. So I think we're all singing from this song sheet. So nothing particularly big there. But for Baya, right, so what we saw, which is not surprising, is AI, whether you call it acceleration on its own or applications of AI, are pretty much everywhere, which drives the heterogeneous or intelligent compute cycle, and the natural transition to system of chips rather than just a system on chip. The way we kind of looked at the market, semiconductors renaissance is going on well. It's about nearly 8% CAGR for the next 10 years, but the subsections of that are growing much, much more rapidly. So chiplets itself is like a 40% CAGR, intelligent compute is a 40% CAGR, but the intersection thereof is like doubling every year. And that's actually our sweet spot. Obviously, it's a non-trivial problem that has too many variables and constraints. So having a fully vertically integrated system like AMD, NVIDIA, Intel have are thriving. ARM is really taking a path towards the same type of approach using ecosystems that transition to chiplets. Most of you are probably familiar with the chiplet specification architecture that they've published. It's still a work in progress, but at least a path towards achieving some of that standardization, some of that interoperabilities, and structuring the system. But clearly the biggest Wild West scenario is around RISC-V and heterogeneous compute that multiple of the players are trying to bring to market, with the chiplet ecosystem being a fundamental requirement to make this happen. We've clearly been working with a lot of them, I'm sure, as you guys are as well. So I'll stop there. This is kind of the fundamental setup for what Bias saw and where it's going. I'll touch on a little bit of where we think the market is as well on the next slide, and then start looking at what we're doing. So any questions so far? So in terms of the opportunity,
So, to
go ahead.
go back to the previous slide, just in your opinion, the rightmost box that you have, which is the heterogeneous compute with the chiplet ecosystem forming. That ecosystem, there's many pieces there today, but it's not a complete ecosystem, which is why the AMDs and the Intels of the world just do their own damn thing because it's so much easier.
Yeah.
How do you, from your point of view, see this evolving, and what timeline do you think things will?
Fair question, right? So I think if I claimed I knew all of that, I'd be a soothsayer and I'd be pretty rich and not doing this presentation. But I think the fundamental aspects of interoperability are key, right? So I think the packaging is moving at its pace. How do you access the packaging, etc.? That's well past my domain, all right? But I do see that progress is there. The cost structures around that are still stabilizing. The FIs and the interoperability standards are still a real battle because it's still incomplete and progressing. But the EDA vendors now, especially driven by a company like ARM, right, an ecosystem kind of motivator like ARM, are moving, which is good. And the good news, at least for the last box, right, is that's a plug and play in an ecosystem that ARM creates, right? So changing, my view is by 2030, there are three main architectures. x86 has plenty of legacy, ARM's growing in there, and RISC-V is the third kind of leg of the stool in different ways, maybe different sections of the market, but certainly all playing together. And AMBA, or a Chai C2C based system, etc., is usable across any architecture, and RISC-V ecosystem will certainly start utilizing it. So if I kind of look at it, packaging cost is progressing on a parallel path. By interoperability, the more I see is also getting closer and closer to the EDA players, making that possible, because that is a point of control to some extent and a point of value, right? And further up the chain, how do I actually design for that in mind? Okay, so I kind of simplify it into three main chunks. And my assumption is that we will get to like some level of penetration to that type of end market in the next 2 to 3 years, but real volume is probably 5 to 10 years away. Does that answer your question?
Yeah, no, I think so. And to the parallel that you have with the cost of packaging, I think that has a strong influence also on how this moves along, because certain buckets that you have here can afford to use any kind of
Exactly.
packaging because they've
Yeah.
got enough margin, but most other folks don't. So I think
Correct.
that's an important point.
Yeah, and so that's the very valid point. And in fact, what we're doing at Via is focusing on those kind of verticals, right, that can afford it. So that'd be data center, networking infrastructure, AI acceleration as a whole, because it's its own vertical in my view, even though it's very different, diverse. Automotive, right, and then some level of network edge IoT. So those are the five. And in data center, we kind of talk about HPC and all of that in that. So those are the five real verticals that can afford it for now. You could probably argue that kind of compute, like mobile or personal compute, can afford it. But those are very captive markets right now, with most of the players being mostly vertically integrated.
Yep, no, that makes sense. Thank you.
So this was the probably the follow-up statement, and I think my story, as you can probably tell, is based on this, right? So if you look at the right-hand side, which is the merchant chiplet TAM, we kind of worked with Markets.us and SemiViki, kind of cross-checked it with a few others. Clearly, you'll see some progress in the next 3 years, right? 2027 looks like a TAM of somewhere around 10 billion, which is not big compared to what the rest are doing, right? Because obviously majority of the vertically integrated, there are hundreds of billions in there. But 2030 and really 2033, it's easy to show a hockey stick, but we do believe that that's when it really hits. Okay. But as a result, you look at the left-hand graph, that's actually where buyers focused, right? So NOC becomes very interesting, not just NOC on a single die, but a NOC that understands the complexities of multi-die, and tooling, integration software that allows you to build with that in mind. And then, of course, whatever auxiliary IP you need to make that happen. So today, that market kind of shows about a little over 1 billion, and the NOC portion of it being about 3/4 of that, or just over half of that. But at least their belief is that, or the projection is that that'll grow reasonably well, and that's where we're focused. It's kind of niche to some extent at this point. Majority of the big activities are going in-house. But as the broader merchant market kind of grows, we can benefit from it and actually be part of the solution. Okay. So from a challenge perspective, what are we focused on, right? So clearly the complexity, how do you analyze, how do you understand? Two, how do you guarantee performance or KPIs from start to finish? Three, how can we actually reduce cost? I mean, packaging cost, we can't do much over, except that we could help with silicon die cost, as well as cost from the types of PHYs you use. And we'll touch on that in a little bit later, what that means. But so silicon footprint, power, energy, packaging, PHY cost can be reduced by what we can do. And then, of course, how to reduce overall opportunity cost by not missing market windows. That's kind of our focus, right? So how can you get the optimal mix of compute per workload? How do you actually get the right caching memory hierarchies and data movement hierarchies? How do you get the right chiplet interfaces in place? Now, we're not doing the interfaces, but we can actually help analyze that. And of course, all the trade-offs needed to kind of achieve that. So this was a slide that I created for the Chiplet Summit, which was focused on how do you optimize, right? And part of Baya's offering is a software set of tools that help you design memory hierarchies, help you partition clusters or multiple chiplets, and then of course build the fabric for each of the components, right? So understanding the data locality and data movement becomes critical. Then using the right partitioning or coherent, non-coherent becomes the other piece. Once you go down to the third level, you say, okay, I'm going to do microarchitecture optimized so that I get the right, not just the local usage, but the most efficient local usage, and then also package it in a way that you are, when you're going across different partitions, you're maximizing that. Once you go one level even lower, how can I share expensive channels? Now, what is expensive now? Wires becoming very expensive, especially as buses and widths grow. Clearly, logic has always been expensive. Can we actually understand that? And of course, then put it all together. What is a global? Once you've gone through this phase, and you go back up top and optimize. So the architecture that we've used is kind of multifold. One, the software that we have will help analyze cache hierarchies, partitioning hierarchies, also the coherency piece. Then our architecture is built on a multi-level. So you have if it's coherent systems, which are still pretty common and growing in the compute space, clearly on-die communication coherency has been solved. Multi-die has been technically solved by the big players, but it gets more and more expensive. How do you reduce that cost? And we've kind of come up with the second layer of coherency mechanism, which combined with software can help you partition that. And that way, whether it is a CPU-based system, a GPU accelerator-based system, you can design the optimal system to maximize the performance while providing efficiency and cost. And then if you talk about the system itself, right? Firstly, you're doing when you're doing a multi-socket system, how are you doing it? Let's organize that. Organize the chiplet architecture, because a lot of both your cost performance challenges come from how you organize that, what kind of files you're using, what are the D2D, what are packaging trade-offs that you're making. So you get the chiplet architecture, then you get the PHY exploration, the D2D portion exploration, and then once you get that sorted, how do you build a chiplet ready network? And so what we build is chiplet ready in terms of namespace isolation, congestion isolation. That's all built into it, so you don't have to have you go into it with eyes wide open, so to speak. And so if you put it all together, you optimize global performance across a system of chiplets, right? Architecturally, and also in terms of the communication paradigms. And then, of course, you optimize local within the chiplet, kind of putting together the final system. So what I didn't show in here is what we also do. We can actually stack different protocols on the same transport. And so that's where actually a lot of the expensive channels that we're talking about, you could have the same wires and kind of shared logic supporting coherent and non-coherent traffic, if the system analyzed can support it, right? There are some where performance requires you to provide the redundancy for maximum result. But having a clear idea upfront on different types of workloads, fully tested, that show you, yes, it'll achieve what your targets are, that's kind of important. So from a summary standpoint, Baya is focused on providing two main components, right? The IP itself, the software, which is Weaver Pro, to kind of do from requirements capture all the way to physically aware implementation. And then the third part is it continues in terms of post-silicon tuning, etc., and also a platform that at some point can become a place to understand interoperability across different chips or chiplets. So that's kind of the top level view. Obviously, the best in class metrics, I will leave those there. Every startup or every company claims biggest numbers. Those numbers are there. We are working with a few players that are pushing the boundaries. So needless to say, majority of our current customer base is looking at breaking some of the barriers with current NOCs, especially in terms of both performance as well as chiplet readiness, right? And those are in a lot of data centers, infrastructure, and obviously AI acceleration domains. So I'll stop there. We have 4 minutes. I have a description of who Baya is as a company. I can do that later, but I wanted to stop there and see how I can answer questions. Has this helped any?
Hi. So this is great. So it's a design tool. How about, do you guys have the Foundry and Package House connections? One of the difficult things that comes up in the is who do you call for the finishing steps, and is there like a cost modeling aspect to these tools?
Currently, no, right? But we are working with IMEC, right? And I think there is a program that they've been working with UCLA, where they actually built those models, and they're open sourcing the front end of it. The library and the cost models can be then API'd in, right? And as a university, they just want to, hey, we tried it out, we showed it, now open source it. So that may be possible. We are working with them to see if we can integrate a lot of that into the tools, maintain it as it goes along. So those for the industry to do it on their own, but also for those that need it, we can actually start plugging those in.
What's the name of the open source tool that's being developed?
Or I'll, if you don't mind, I'll just send it to you.
Okay, that sounds good.
I'm quite old, so
Okay.
some of the names kind of slip my mind at the moment.
Yeah, I think, John, they published this a little while
Yeah,
back.
I think Puneet Gupta is the
Yeah,
professor.
Puneet is the guy who does this.
Yeah. I think I saw that publication and I was trying to remember the name myself.
Hey, Nandan, it's Cliff. How are you doing?
Hey, Cliff, how are you?
Good. Listen, is there any thought to security-related analysis around this going forward at some point?
So, absolutely. But we're kind of building the airplane as it goes forward, right? So today we're focused on kind of the NOC side of things, which is the multicasting. So we do have error checking, reliability, all of those come in. We have the multicasting, all of that come in. Securities kind of builds on that, but yes, I think we will be working through. But maybe I should stop there and ask you a question. Is that what you meant, or something different?
Well, I was thinking about that as well around the network on the chip, but also around the security posture for the chiplets themselves, around the hardware root of trust and that kind of validation that the chiplets are the ones that were expected to be in the system, and key management, things like that. There are some projects at OCP that are covering that now that might be usable.
Yeah, I think that'd be great for us to talk about. What I've usually found in the security space is the most secure thing is you don't tell anyone what you're doing. Right? So small companies take a long time kind of getting into that inner circle. But I think what you said is let's look at those groups within OCP that are working on that, and we may have something to help with that and take that kind of mental.
Okay, great, thanks.
Security.
Yeah, that's useful.
Security.
Go ahead.
I was just going to say security through obscurity. That's
Exactly. So I think for whoever asked about the tool, the NanoCAD group within UCLA is the one that's doing it, right? And so if you actually just Google Puneet Gupta NanoCAD, I think you'll find what you're looking for. Okay, anything else?
So I have a question, if you go back to the previous slide.
Go ahead.
Okay, so here, I'm just trying to understand the current model you have to work with customers is you're designing a custom NOC for them, and such that they can drop in their pieces based on Chiplet or otherwise into the sort of openings. And there is connectivity already built in for a specific application. So it's customized for an application because an application dictates what needs to be on that chip.
Yeah, so we provide the tooling and the IP that can be put together for it. And as you probably know, right, I love for it that you've made it a geocentric view rather than a heliocentric view. I'd love for it to be, oh, we put the system in place and they drop in their pieces. Usually it's the other way around. We help them understand where they need to go. They drop the big talent, so to speak, that does compute, and then a system has to fit in whatever crevices are available in the chip apart from the main highways, right? But yes, our goal is to enable them to go do it themselves with the tooling, right? So that they can tweak, tune, customize, and really everything that we do is API connected to existing EDA tools, right? So we have System C APIs, C++ APIs, and then for the front end to kind of help analyze, we have Python APIs. So it can plug into your modeling environment, it can plug into your implementation environment, and you can build a customized, optimized system NOC.
Okay. So ultimately the goal is to just enable the customer to build it entirely by themselves.
Yes.
With all of the software that you can provide them.
Correct.
But
Correct.
right now probably some amount of hand-holding to get through the process.
Yes. So and I was just going to touch on one thing before, right? So this is the company. It's the key founders, Dr. Sailesh Kumar, Eric Norridge, Philip, came from NetSpeed Systems, which did the first iteration of this, then get acquired into Intel, and then now spun out for the third generation. This was actually driven by Jim Keller, who kind of actually pulled Sailesh Joji out and Eric out of Intel, saying there's a gap in the whole NOC, chiplet-ready NOC space that you guys need to come fill. And Intel Capital obviously invested, Matrix invested, the second Series B was invested in by Maverick, and Synopsys also joined us as a strategic partner. So we are trying to plug into the right places to kind of help make this possible to democratize the capability of building chiplet-ready optimized systems.
So this could actually work if it's not chiplet based either, right? If it's just IP.
Yes.
Okay, got it.
So the first set of customers are really looking at kind of breaking the boundaries on what an SoC can do, but they're also looking at one SoC is not going to cut it. We need to tile these into multiple chiplets, etc. So it's a combination of both, but really majority of the value still comes in from optimizing the SoC today.
Right.
The chiplet readiness is nice, but will be necessary in a few years, right? So
Yes. Yeah.
in
What you're
my
saying is you can transition to the chiplet using your same NOC in different.
exactly.
Yeah. Okay.
Yeah.
Makes
If I
sense.
may, I also have a follow-on question.
Go ahead.
More for the audience and our community listening, as I'm very happy that Baya Systems is a startup member of OCP, and obviously part of what we want to see is more engagement as possible with our startup members and the community. And so I wonder how the capabilities of the software that Baya has could be advanced in the marketplace by certain standardizations that are in the community. I see touch points with the systems workstream that just got launched. I also see touch points with the modularity workstream that has been going on for about a year right now.
Mhm.
And there may be others.
Yeah.
So I'm asking the rest of the community on the call, where do we think there might be some synergies here that would be worth exploring?
Hey, Cliff, this is Durgesh. So I've been working with Baya for over a year, closely
Durgesh.
connected with Nandan and Salesh. So I'm running the systems work stream, so I was already planning to bring them in.
Okay, can you give us a little idea? Do you have some idea yet about what that looks like, and can you share?
Yeah, so currently the first deliverable or first activity which Baya is involved is the NOC. And they have a methodology to bring the coherent as well as non-coherent, and then Nandan is a term of something like IO coherent, which is the middle one. So in the chiplet world, Cliff, the issue is how do you connect multiple chiplets? So using the NOC as the center from the say main chiplet, CPU chiplet, that will be the centerpiece and it will help us connect to other chiplets on the NOC in the CPU. So NOC is providing the backbone of connecting multiple chiplets so that they can talk to each other successfully. You brought about the security questions. So root of trust generally exists outside. Confidential compute is required. So all those things, NOC provides the backbone, and then we build the system on top of the NOC, whether it's coherent or non-coherent. NOC, that's kind of at a high level we want to approach it.
Okay, that's really exciting. And you know, if I put my imagination hat on for a moment, I see the NOC as the center, and then if we maybe bring in the concept of sockets that's been talked about as well,
Yes.
standardized sockets, we can now see standardized form factors coming out with a set of sockets interconnected by a NOC that is a pre-built prototype for an SoC, where then chiplets can be dropped in.
You summarized very well. That's exactly right. And that's where Nandan's vision is as well. And we are fully aligned on that one. That NOC is the backbone, NOC is the centerpiece, and everything surrounds it, and you can scale up and scale down. The reason it was very interesting is because you can very easily scale up and down by enhancing the NOC itself. So you can have 1x1 NOC, 2x2 NOC, and you have more computing power. So it's a very powerful solution which Nandan and Salesh are working, and that definitely we can use as a backbone for the systems working group.
Yeah, I see. It's really exciting that as we move forward, if we can have some standardized sockets and NOC
Yeah.
combinations, because right now it seems like it's an ad hoc custom world, and
Yes.
you know that's expensive. If at some point it becomes, well, we can still do custom, but we've got these 5 or 10 designs that cover a lot and really reduce the costs. That'd be awesome, and those can be described as specs through the OCP and shared with the community.
Yeah, I think that makes sense. And that will depend on Nandan how much they can make it a standard versus implementation. So yeah, those are logistics. We can definitely talk about
I
it. But
think
yeah, I agreed.
no, I think this is great, right? So I think Cliff, I think you've done a good job of giving me actions for after the call, right? And hopefully connected us to the right people. Durgesh, I worked with for a while, so it'll be easy to reconnect on that. We'll probably look at whoever else is on the call. You have my email. You can reach out to me, and if not, Anu or Mark or Durgesh can always help you corner me.
Yeah, I think it might be good, Anu, for Nandan to talk also with Patricia and George from the
Yeah.
modularity workstream if he hasn't already.
Yeah.
Yeah,
I was
so
gonna say
yeah,
that.
Patricia's here.
Oh,
Yeah.
you,
So
Patricia.
I was
Okay.
gonna say that. So as part of the work stream, we are working on a white paper that is going to explore modularity for artificial intelligence. So we have had some progress on that. It's been exciting because we've been getting a lot of interest from the workstream members. And basically what we have is that we have been able to define four different, or at least four different products that we could build using modularity, because the HPC and AI chiplets is about modularity, that workstream is about modularity. And then we're trying to get all these, trying to gather all this information that is required to have high level evaluation of what those different systems would look like built out of modular chiplets. So yeah, I think very relevant, and it would be great if we can have a conversation to see how can so how can we help each other.
Okay, that sounds great. So let's set up another chat on this where we can dive a little bit deeper. This is just to give you a top level view, right? And I think I'll be in the Bay for. I'm based in Austin, by the way, like Mark. And then I'll be in the Bay for the Andes Risk Con, so the week of April 28th. Our offices are pretty much right next to the convention center, so at any point you want to deep dive a plan for that, we can set it up and go further, especially on the modularity perspective, system kind of software API perspective. The right persons on this would be our chief software architect, a guy called Eric Norridge, who's right here. And so let's set it up. First, let's kind of understand what we're trying to do, and I can connect to the right people that can take this forward.
So Nandan, when I sent you the mail yesterday, I sort of listed all the work streams that we have, and the two that Cliff mentioned are quite relevant and can make use of what you guys are thinking about, sort of this synergy there, which is the new work stream we're starting. Durgesh, Itai, who's also on the call, and Rob, who's also on the call, are the three leaders, the work stream leads for that new work stream.
Cool.
The first meeting is on Tuesday at 12. And I know it's short notice, but it would be great if someone from Bayer can join that call. It's 12 p.m. Pacific time. And I can send you the invite.
Yeah, if you send me the invite or the timeline, we'll have somebody there.
Yeah, sounds good. And then the other work stream is the one that the modularity work stream that led by Patricia and George, who are from Lawrence Berkeley National Lab. That's been actually moving along quite well. And as she said, there's a lot of interest, but I think this also fits quite nicely into that realm, which is why I sent you the list of work streams yesterday, because there is direct connection. And some of my questions to you about, is your solution a custom solution versus getting to a point of nice, clean modularity, which is the ultimate goal and vision for.
So I'll say this, right? So that's once you think about a chiplet, even actually within the SoC, the software and the tooling is designed to create more tiled solutions, right? So effectively what you'll see is some of these things end up being very repeatable, right? And so we actually create there's a tiling boundary that you can create within the tool kind of guides you through it. And where that helps is also then implementation becomes easier because it can be physically where if you need to rotate, reflect when you're implementing it, that's kind of built into how the tool understands and analyzes it. So modularity is actually a strong keyword for us as well.
Yes, we see a lot of alignment here.
Good. Wonderful.
Any other questions for Nandan?
Hey, Nandan, this is Anshu Bahadur. I am part of SEMI, which is a semiconductor consortium, and we also run an APHI work group, which includes IEEE, HIR, and a whole bunch of other people. At some point in time, if you're okay with it, I was thinking we have a monthly meeting, which would go to give a good interconnect for you and others from our ecosystem to talk to Baya. Would you be open to presenting something similar there?
Steve, we're a startup. We love presenting anywhere.
Okay.
So let's discuss the specifics, right? And then we can talk about it. And right now, I think we're just reaching that point of critical mass where we're assimilating new talent. We're getting more customers kind of sorted out. So we're beginning to kind of come up for air and look out again. So I think this is a good time for us to engage with that. And also this is helping us kind of focus our energies for the next year on where we want to go. And so a good time for us to understand that.
Yeah, we would be able to hopefully facilitate some connects or interconnects with our larger ecosystem
That
and
would be
vice
great.
versa. Thank you.
Great. Cool. Nice meeting you, Anshu.
Yeah, same here.
Okay, anything else for Nandan? I will share your email address, Nandan, with Patricia, so she can set up a separate meeting. They meet every second Tuesday, but she may want to talk to you separately, to give you a good
Sounds good.
background. Yeah. And then I'll send you the link to the other meeting. Thank you very much. Appreciate
No,
it.
thanks for having me. I think this is great to both get the exposure with the team. I've met quite a few of you independently, but this is good.
I'm sure you had a question.
Yeah, can you share Nandan's email with me also so that I can get in touch with him?
Yep.
Thank you.
Yeah, sure. I think he has it somewhere on this presentation, don't you, Nandan?
Yeah, I can send you the presentation. I can, if it's not there.
Or you can
I'll
just
put it
type it
on.
on the chat, Nandan. That way you can get a lot of email.
Yeah.
Alrighty.
Because you aren't getting enough in a day.
And if this presentation is, if you can share, that'd be great too. Just for
Happy
us
to.
to. Thank you.
Okay. Thank you so much, Nandan. Appreciate your attending, and I will take care of the action items from my end to make sure Baya is involved in the work streams that make sense for them and us.
Perfect. Thank you, guys.
Thanks, Nandan. Okay, any other action items for our end? As advertised at the start of the meeting, the new workstream, Chiplet system workstream starts Tuesday, 12 p.m. Pacific time. Zoom link's been sent out. Please do join. I need to update the wiki page, but apparently I lost my, as Jawad told me, I obviously lost my login and password, so I need to ask nicely to get that back and then go fix the wiki page to reflect it. As Jawad mentioned also, the POC workstream, which we are reviving after being dormant for some time, meets at 10 a.m. Pacific time today. That link, I think, exists on the wiki already. So please do join that one if you're interested in how to get to a point where you can test out your chiplets in a ready framework, which was the original vision of the proof of concept group. That's all from my end. Jawad, Cliff, any final thoughts?
Nothing from me. Thanks.
That's it for me too. Thank you.
Excellent. So we will end 11 minutes early today, which is fantastic. Thank you all for attending, and I'll get down to all the action items that need to be taken care of. Thank you all.
Thanks, Anna.
Thanks, everyone.
Bye.
Bye.